Opie claims that 6,345 is divisible by 15 because it is divisible by both 3 and 5. Show that 6,345 is divisible by 3. Well, we can add the individual digits up. 6 plus 3 plus 4 plus 5 is equal to 18. And then if we need to do that, I can see that's divisible by 3, but if we need to go further, 1 plus 8 is 9, which is divisible by 3. So, yes, it's divisible by 3. Show that 6,345 is divisible by 5. Well, we can see the last digit is 5. So that's a yes. Remember, for 5, the last digit is a 5 or a 0. Is it divisible by 15? Let's go ahead and check on the calculator. So 6,345 divided by 15 is indeed divisible. We can see that because we get a whole number as the quotient. So that also is a yes. Opie also claims that because 51,948 is divisible by both 2 and 4, it is divisible by 8. Show that it's divisible by 2. Well, the last digit is an 8, so it's even and therefore yes. Show that it's divisible by 4. Well, 48 is equal to 4 times 12, so it's divisible by 4. Remember, for 4, the rule is the last 2 digits need to be divisible by 4. Is it divisible by 8? Let's check on the calculator. So we've got 51,948, and we divide that by 8. And no, it's not, because we get a decimal answer. So the answer there is no. Explain the results from parts A and B. So in part A, we showed it was divisible by 3 and by 5, and it told us that it was divisible by 15. In part B, we had 2, we had 4, but then 8 didn't work. Now, the reason is that 3 and 5 have only one common factor, and that is 1, and all integers have a common factor of 1. Whereas we know that 4 has 2 as a factor. So in this situation where the two numbers we test have a factor, you can't necessarily imply that it's going to be divisible by 8. It may be, or it may not be. But in the case where the two numbers we test don't have a common factor other than 1, we can imply that it will be divisible by the multiple of those two numbers. So in this case, 3 times 5 is 15. If we had, for example, a test for 7, there is a test for 7, but you don't need to know it. If we knew that 3 was true and 7 was true, 21 would be true. However, if we know that 5 is true and 10 is true, then 50 may or may not be. We don't know because, of course, 5 times 2 is 10, so they have a common factor of 5. So it's only in this case where they have no common factor other than 1 that we can go ahead and say that a number divisible by 3 and by 7, for example, is divisible by 21.